Hi, guys.
Hello again.
Looks like I got five of you with me. We'll just leave it for just a couple minutes. This should be fairly quick. The experiment itself is not that hard, and it should be fairly quick to get through this, okay? Just let's give it another minute or two to see if somebody else wants to join us. We doing okay, guys?
Yeah, can't
Good. How
complain.
about you?
Good, good. Did I bore you too much, Blake or Dylan?
No, not at all.
Yeah.
Okay. Come on, it's dry. That stuff has got to be the driest stuff you have ever. No, maybe not. Maybe, has anybody ever read Ulysses?
Yup.
You've read it,
Can't say I
Dylan?
have.
Dylan, you've actually read it?
Yeah.
God bless you. I got through the first sentence and said, no, my life is too important to go through this crap.
It was definitely for
Does it get
school.
better? Does it get better after the first sentence, Dylan?
Not really.
I just waded my way through the old Curiosity Shop. And I was so happy. I got done with it on Sunday, and I was so happy that I'll never have to go through that book again. I have just
That bad?
I'm sorry?
That bad?
Yeah, well, it wasn't the worst book I've ever read, but it also wasn't the most exciting. The last 100 pages really fairly flew by, but God, it took him 6 pages to describe Nell dying. That's not quite it. Has anybody ever read Les Mis? Do you know what I'm talking about? The Hugo book, Les Mis? Okay, how about the musical Les Mis?
Heard of it.
Heard of it. Victor Hugo, in one point of this book, took something like 30 pages to describe the end scene of the Battle of Waterloo. Then, subsequent to that, later in the book, he took about 30 pages to describe the sewers of Paris. Other than that, it was a fantastic book. I felt that I had to read it before I went and saw the musical, and I was glad I did. Okay, it looks like we got 7 of you here. That's fine. This one is not really that hard. There will be some labs in the future that are going to be hard, so it's a little bit problematic whether you skip these things or not. All right, this one should be fairly simple. Okay, we're going to go to the homepage. You guys see that you're seeing my screen with
Yep.
the homepage of the course,
Yep.
right?
Yeah. Yep.
Okay, we're going to go to course content. I want to show you one thing before I get started here, okay? At the very bottom, and there's a lot of stuff in there, there's a thing that says other information. If you click on it, then you got to go all the way back up. There is a site on how to draw a graph in Excel. Guys, I don't care that you hand graph this stuff. Yeah, it was probably important for you to learn how to do it once so you get to know what things mean with one another. By all means, you are literally, when you get out in the real world, you will never have to hand graph again. You're more than likely going to learn how to do it in Excel. You might as well learn it now. Just click on that. That will lead to a Word document that has the website on it. It's fairly good. The gentleman that does the narrating is Indian, so sometimes you may have a little bit of trouble understanding him, but he's very good. very succinct, and it goes through the procedures step by step. That's why I like it. So that's the first thing in there. The second thing that you're going to have to know, you go down again, and you are going to see something that says student data for labs. You're going to click on that. This you have to do. Then going to go all the way back up, and you're going to open it. This is where you are going to find all of the data for your experiments. And the data for the density experiment is right there. Questions, guys? You also have to submit a notebook. I'm going to drop one of the notebook submissions. So if you didn't do the one that was supposed to be handed in today, don't necessarily worry about it. But if you missed today's submission, then you have to submit all the rest of them. Somewhere in here, I have an exemplar of a lab report. If it's not in there, I will put it in other information. Questions so far? Okay, going to go back to table of contents. Now, ladies and gentlemen, if you didn't do introductory laboratory, then you have to understand what is going on with the submissions. I'm going to pull up the results section here in a moment. Okay, it'll pop up here in a second. All right. You are getting the mass of the aluminum bar and the mass of the sphere. Those are measurements. Measurements, you do not need to show a calculation. So just in this, simply enough, just put A, 54.321 grams, and B, 10.685 grams. That will suffice for me. Now, in the second one, you are supposed to show the volume calculation for the aluminum bar. You have been given length times width times height. So I need you to put on here centimeters times whatever centimeter you have. If your length is 14.543 centimeters, you got to put 14.543 centimeters, then put the X in, 7.32 centimeters times 7.32 centimeters, then you put the X in again. Okay, I believe what he has done is he has done the volume for the sphere is by displacement. Basically what you do, and I'm going to get into this when I get into the slideshow, you're going to have the volume of the graduated cylinder that you have initially, then supposedly you're going to put the sphere in, and you're going to have a final volume. So you have to put the number here. You have to put the label there. You have to put final volume minus number, label of the number, initial volume. Okay? Then you have the final answer. The final answer is volume of the sphere. Do we understand what I want in the text boxes for calculations? Is there any confusion, guys? If you do not put the verbiage in there, you lose half the points. So if you don't put the verbiage in there describing the number, you only can have 10 points out of that.
You mean final and initial by verbiage?
Yeah, yes, that's what I mean. Just final volume in GC, initial volume in GC, and you also have to put the milliliters. Fair enough? Same thing with the density. You're going to show a calculation for both of these. And basically, all it is mass of the aluminum bar divided by the volume. Okay? Fair enough, guys?
Yep.
If I can understand it, you're good. If I can't understand what you're writing, if you are too abbreviated, then I will take points off. Significant figures matter. All right, this question. You're going to have the mass of the empty flask. We only want trial 2 calculation shown here. You need to show the calculation of the mass of water. Basically, you have the mass of the flask with water minus mass of the empty flask. That will give you the grams. For trial 2, show the calculation for the volume of water. Okay? Final burette reading minus initial. What you are doing in this experiment is you are adding a certain amount of water. I believe it is 5 milliliters each time. So in order to get the volume, you have to show the initial burette reading and the burette reading after it's reached about 5 milliliters. So you would have to do 5.00 milliliters final burette reading minus 0.00 milliliters initial burette reading to get the volume of the water. Then for only trial 2, you show the density calculation for the water. What you are doing here is you are doing 5 different measurements of the mass and volume of water. And you are going to take those 5 volumes and you are going to graph them. The mass should be on the y-axis. The x-axis is the volume. That's because you are controlling the volume. You are controlling how much of the volume goes in at a time. So therefore, it's the independent variable. It goes on the x-axis. You have no control about over how mass it is, over how much mass there is there. That has everything to do with what the liquid's density is. So you are going to get there and you are going to calculate the mass. And you're going to get your 5 points, draw your best line. Then you are going to do the slope of that line and determine what the density is using the slope. Any questions on the results section, guys? Anything?
No.
Okay. Now let's get into the calculations. Nope, that's not it. Oh, I don't have it up. Okay, we are going to get out of this right now. All right, great stuff. Okay. This really is fairly easy, guys. There we go. Can you see the slideshow?
Yep.
Yes.
Thank you. Okay. Just going over this real quick. The density triangle. The density triangle is mass over density volume. There's a line between mass and density. So if you have the mass and you have the density and you want the volume, You divide the mass by the density and you get, stop it. You divide the mass by the density and you will get the volume. If you have the mass and you have the volume and you want the density, there's a line between the mass and the volume. Therefore, the mass gets divided by the volume. You have the density. If you have the density and the volume and you want the mass, you take the density, you multiply it by the volume, you get the mass. So density problems are very simple. You either are given two things or you have a way of getting the two things. You solve for the third. So if we're dealing with liquids, the volume can be measured directly. All you got to do is pour the liquid into a vessel. Or in this case, you can take a burette and note the initial volume, pour the liquid into your flask, stop it up, and you know the final volume. You subtract the two volumes, you know how much was delivered. However, you cannot measure the mass of the liquid directly because you can't just pour the liquid on the balance. What you have to do is you have to weigh the empty vessel, then fill it with liquid and weigh it again. The weight filled minus the weight empty equals the weight of the liquid. You have the mass without the liquid is 32.643. The mass of the flask and the liquid is 42.893. Mass of the liquid is equal to 42.893 minus 32.643. The volume of the mass of the liquid is 10.250 grams. I have divided the 10.250 grams by the volume. I have my density. Questions, guys? Okay, if I have a solid that is regularly shaped, I can directly determine the mass. All I have to do is hit the button on the front of the balance that tears the balance. In other words, resets it to 0. Then I place my solid on the balance. I just read the mass. If I have a regularly shaped solid, I can determine the volume with a formula and measurements. If I have the volume of a cube, all I got to do is measure one side, cube that, and I have the volume of the cube. Volume of a block is length times width times height. Of a sphere is 4/3 pi r cubed. The volume of a cylinder is the height times pi times r squared. So I'm able to use the formula and the measurements, and I'm able to get the volume. I already have the mass. All I have to do is divide the mass by the volume. I have the density. Bar has a length of 7.80 centimeters, a width of 4.75 centimeters, and a height of 1.45 centimeters. Its mass is 354. What is the density? Volume equals length times width times height. All those numbers out there. I multiply them out. The volume is 53.7 centimeters cubed. My density is mass divided by volume. 354 grams divided by 53.7 centimeters cubed. I end up with a density of 6.59 grams per milliliter. Questions, guys? If my solid is irregularly shaped, I have to use Archimedes' principle. Basically, what I have to do is I have to fill a vessel with a liquid. I have to note what the volume is to begin with. Then I take the solid, put it on the balance. I get the mass of the solid. I then take the solid, place it into the volume gently. Then once I place it in there gently, I note the final volume. The final volume minus the initial volume gives me the volume of the solid. Just divide the mass by the volume. My final volume was 25.3. My initial volume, 17.8. My mass is 6.543. 25.3 minus 17.8 gives me 7.5 milliliters. I divide my mass by my volume. I end up with a density of 0.87 grams per milliliter. Density by graphing. What you are going to do is you are going to vary the volume and determine the mass of each volume. So you're going to have points. You're going to have one of the values being the volume, one of the values being the mass. So you're going to figure out your scales of your axes, and you are going to plot it out. You're going to go over the X value, then up to the Y value. Your second point, your second experimental determination, you're going to go a little further over on the X axis. You'll have to go a little higher on the Y axis until you get all 5 points plotted. Then if you're hand grafting, you have to draw the line of best fit. What that means is you have to kind of like draw the line so that you have your points above and below where the line is. What you are doing by drawing the line of best fit is you're averaging out the measurement errors. Then, once you get your points, you have your line drawn. And this really is not, you can't see things too well on this slide. I apologize, but it's the best that I could do. Okay, my point one. My point one was right here. That point one was 2 blocks away from 3.0. Each block was worth 0.25. So that meant my X value was 2.5 milliliters. My Y value was right on the line at 20 grams. All right. I looked over at my 4.75, which is 1 block over from the 4.50. Since each block is worth 0.25 milliliters, this makes the X reading 4.75. That's also on the 40 gram line. What I am doing here is these small boxes, I know you can't really see them very well, but what I am doing is I'm finding a spot on the line in which it goes through the very corner of the box. Like if this were the box, I would be trying to find a point where the line went right through that edge right there. Now, once I do that, I do the slope calculation. Slope, change in Y over change in X. Change in the rise over the change in the run. The Y values are 40 and 20. So I have 40 grams minus 20 grams. That gives me 20 grams. My run is 4.75 minus 2.5. So I subtract those out and I get 2.25. I divide 20 by 2.25 and my slope is equal to 8.89. If you kept your labels there, you know that the denominator, the label of the denominator is grams, the label of the numerator is milliliters. So the value of the slope is in grams per milliliter. The slope is equal to the density. That's all I got for you guys. Any questions?
Nope. That's it for the whole lab.
Yeah. The only other thing, I'm going to stop share right here. And this is valuable for you if you want to go through it. It's 11 minutes out of your lives, guys. My quizzes. Yeah. Okay. If I go back And I don't know that I can. I'm gonna have to get out of this, guys. And I am going to have to reload it. Sorry, it'll just take me a few minutes to reload this. What happened is sometimes in my screen, it will kill the scroller. Two more screens to go. And we're back. Okay. Okay, you seeing the screen now? The home page?
Yeah.
Okay, when you go into course content, there are a couple things in the density packet that are worthwhile to you. First of all, Dr. Musgrave has a video going through the entire procedure. If you're not understanding it, looking at the data and looking at the data and looking at the results section, then I would highly suggest going through the video. It's 11 minutes to go through all of this. There's a thing for sig-fig rules. And this density calculation is the PowerPoint presentation that I just went through for the calculations if you need them. This is the Dropbox. This is where you're going to put the notebook. You're going to put the notebook for density in the Dropbox by next Wednesday.
I have a question.
Tuesday. Got an answer.
Yeah, for the last notebook I did, it was just the two tables and then what we were doing and the synopsis. And then there was no, like, we didn't have to put any numbers or anything, calculations,
No,
right?
there are no calculations. What you needed to put in there is an objective. One sentence,
Yeah, objective.
one
Yeah, I did
sentence
that.
determining, just saying something to the effect of, we are determining whether mixing certain chemicals are chemical or physical changes.
Yeah,
That would have
okay.
sufficed for your objective. Then you got to go through and do the procedures. And that particular one is a bit of a pain because you're dealing with, how many was it? Like 7 or 8 experiments?
Yeah.
So you got to put each one in separate sections. Then, as you said, you fill out the data page that was provided, the data table that was provided for you. Yes, there are no calculations in this one, but you also have to deal with the results section.
Oh, so you had to go through before you did the tables. I thought the tables explained it. So you're supposed to go through and say, we're mixing this with this.
Let me give you
I printed out that table and then I put the mixture, like 2 liquids, and then I wrote what happened. And then I wrote chemical or physical.
Okay, let me show you. Hopefully it'll pop up. I'm going to stop share. Okay, and hopefully it's somewhere. There it is. Okay, you got to deal with this because I managed to put the second page first. All right, first page, objective. Okay. The objective for that experiment was to determine the mass percent of water in a hydrate. Notice, guys, I made mistakes. You don't scratch it out. It has to be written in pen. You don't scratch it out so you can't see the word underneath. Notebooks are made like this. You want to make sure that the original text is there to show that you're not hiding something. So basically, you just draw one line through it and correct it over above. You don't have to do chemical hazards. I decided that since you're not actually working with the chemicals, that it's not absolutely necessary for you to do the chemical hazards. All right, that was the first page. Then we went to the second page, which is the procedures. Simple step-by-step directions as to how you did what you did, or how you were supposed to do what you did. Okay?
I
Then,
totally did not do that.
then you have a data table. Don't worry about it. First one, you have no idea really what I'm looking for. So how do you know? Basically, data table, you can copy and paste it into your notebook, but it has to be in your notebook. It has to be cut and pasted in. These are all the datas. Once you get to a calculation, I do not want you to put the calculations in amongst your data table because it makes things too confusing. The calculations I want from birth to death. You're going from, both of these things are measurements. I came up with the calculation from that. Again, both measurements, calculation, measurements, calculation. Then I have two calculated values that I use to make another calculation. That gave me my final answer.
So you just want the product in the data table then?
Yes, yes. Okay.
Okay, I think I
Then
get
you
it now.
have the results section. The results section, the first sentence should answer the question raised in the objective. The objective was to determine the mass percent of water in the hydrate. First sentence is, the mass percent of my sample was 50.11%, which compares favorably with the actual value. Okay? My error analysis. I said we live in Florida. It's a humid climate. It's possible that the anhydrous sample could have absorbed H2O. I looked at the experiment itself and I tried to find out where something could have gone wrong with it. Then I not only did that, I analyzed what I did say and I made a statement as to how that would have expected, or how that would have affected the actual result. Any questions about that, guys? I will put this, I'm going to put this exemplar in the other information portion just as soon as I get off here, okay?
Okay, thank you. Have a good night.
No problem. Anybody else still around? I still got 6 of you here.
Yeah.
That's really
No,
truly all. Blake, you have a question?
no, it was, I did have a question, but Kevin's question answered that. So I'm
Oh,
good.
is that the notebook?
Yeah, I definitely messed up the first one. I'll make sure the second one's better.
Don't, I mean,
Yeah, I
literally
didn't-
speaking, don't worry about it. Don't
Okay.
worry about it, guys. I'm not that concerned about it. Don't you be concerned about it. What I want eventually is I want you to do one assignment where you turn in a good notebook. I want you to prove to me that you can do it. Okay?
Fair enough.
So we error page, will we have to like how would we go about filling that one out?
The error analysis. Okay, Khalil. All right. Can I ask you a question?
Yeah.
Do you know the relationship of density with temperature?
No. Not
All
off
right.
the top of my head.
Mass is not affected by temperature. You could take 20 grams of gold and be at room temperature where you're handling it, or you can take that gold to its molten state. It still will be 20 grams of gold. All right, you take it on Mars, it's going to be 20 grams of gold. That's what it is. The weight on Mars will be different, but the mass will not. Mass doesn't change. However, think about water. If you take the temperature of water and you change it, say you freeze it, Khalil, does the density of water change?
Yes, sir.
So temperature is affecting the volume, right?
Yeah.
So what would happen if the temperature of the room was so hot that it made the volume expand?
And you,
Volume, remember, in density, it's grams divided by volume. The volume is bigger than you think it should be.
then you'd get a lower density.
Then you get a lower density. And that's what I'm talking about. Okay, Khalil?
Okay.
Other than that,
Thank you.
guys, anything else? Okay, I
No.
will upload that report. And oh, one more thing. Crap, I forgot to tell you this. I did tell you this, didn't I? Didn't I tell you where the Excel thing was in the other information?
Yeah, you did.
Okay, thank you. Thank God. All right. You don't have to hand graph this crap. You're going to have instructions on how to use Excel. Guys, I can't emphasize enough, learn it. You're going to be doing graphing. If you're going through Chem 2 especially, you're going to be going through a lot of graphing in Chem 2. Learn how to do Excel now. It will save you lots of headaches. Once you learn how to set it up, you're not going to believe how much less time it takes to do it that way as opposed to trying to do it hand grafting, sorry. Other than that, I think that's all I have to say to you, okay?
Yeah.
All right,
Thank
good
you,
night.
sir.
Khalil?
Thank you. Have a good night.
You're welcome. Khalil, do you have another question?
No, sir. Thank you.
Okay. Take care, guys, and see you, some of you on Thursday, the rest of you next Tuesday. Take care.
Bye-bye. Thank you.